a few days ago when we introduced logistic functions, I'm going to flip back and you can as well in our notes. We said that there were two basic models for logistic functions. You could either use a times b to the x or a e to the negative kx. You can choose to use either one when you're modeling. I'm going to choose this one, okay? And you would get some different numbers for the k here, basically, if we did it that way. Let's write down then our general logistic equation. You don't have to memorize that, okay? In general then, we're going to model this using c over 1 plus a times b to the x power. Hold on, I'm flipping back. I'm going to just write this down for us, so if you want to try this way, you can. So then let's go through the problem and figure out what do I know, or what do these things tell me? So what's something I know right away that I could put right into my function? Nate? Yes, this limit to growth is c. Okay, so we for sure know then that f of x equals 60 over 1 plus a times b to the x. And even though it's tempting, we're not going to put 12 in for a, because this is not an exponential model. Question? Oh, you're going to tell me what to do now. Yes, I have points, right? And so what I'm going to do is I'm going to find a and b using those points. You're going to want to use the initial value first. So Nate, the initial value is 12, but what does that mean about x? The function is 12 when x equals what then? 0. This really is the point 0, 12. So in the function, I'm going to put 0 in for x and 12 in for f of x. So here we go. So what's b to the 0 power? 1. So now on the bottom, I have 12 equals 60 over 1 plus a. And this is an equation you have solved before, even though you might have forgotten. When we have a variable on the bottom of the fraction, we cannot solve it that way. We have to move it to the top. So we're going to multiply through both sides by the denominator. So then what happens on the right side of my equation? Cancels. Okay. Then on the top, let's solve that. So I'm not going to distribute the 12 because I think it might be more. Well, you can. We can do it either way. How would you solve for a? Yep, we're going to subtract 12 from both sides. 12a equals 60 minus 12 is 48. And we actually get a pretty nice number. A is equal to 4. All right. So now in my general equation, I know C. It was 60, right? Now I know A. What's A? 4. Now I'm going to use the same process to find B. Are you given another point? 124? Okay, so we're going to plug 1 in for x and 24 in for f of x, and we're going to go through the same thing, and we're going to find what B is. So back up here we have 24, that's what f of 1 is, equals, we know the top is 60, we know this is 1, now we know A is 4 times b to the first power. by the way, I could give you a different point, but then it would be like b squared or b cubed or b to the fourth, and we got to remember how to undo those things. Like, how do you undo b cubed if I were to solve the cubed root? Okay. Trying to give us a little algebra refresher. All right, I'm going to do the same thing as last time. I can't solve this with b on the bottom. So what should I do? Multiply both sides by 1 plus 4b. All right, so then on this side I have 24 plus, what's 24 times 4? Okay, so 96b equals 60. So what should I do? Subtract 24. Okay, so 96b equals 36. So what does b equal? Okay, so b equals 3, if you reduce the fraction, 3 over 8 or 0.375. Either is acceptable. So now I also know b. So let's put these things all together. Our exponential function, no, our logistic function, excuse me, is f of x equals 60 over 1 plus 4 times 3, 8, or 0.375 to the x power. Good. So yesterday, the last thing we did in our notes is we did a regression of the population of the United States from 1900 to 2000. Do you remember that, putting that stuff in our calculator? Well, you don't remember because you weren't Tuesday. Okay, so what I would like us to do is let's revisit that again. So let's go back to page 293.